All right, hi guys. Um, we have finished up the exponential functions and exponential and logarithmic functions unit. We are now going to move on to the polynomial unit. The first few, this video is actually going to be or feel pretty familiar to you guys, so just keep this in mind. It is going to get. I am going to try to cover as much as possible in this one. That way, the next few videos become a bit shorter. Okay. All right, so let's go ahead and start. So for this unit, this video, we're actually going to be adding, subtracting, and multiplying polynomials. Okay, this is part of your TEKS. Okay, so 7b, you guys or the students are expected to add, subtract, and multiply polynomials. But before we get into that, let's go ahead and talk about what a polynomial is. Okay. Even before learning what a polynomial is, you have to remember that what a monomial is. And in order to know that, you got to remember that mono is a root word. Okay, it's a root word meaning only one or one only. Okay, so whenever we have a monomial, it means only one term. For an example, what a monomial is, it just means one term. It's like 3x. It could be 5x squared. It could be 1. Okay, and these are just examples, but there are plenty others. For a polynomial, we need to know what the root word poly means. In this case, it means one or more. Okay, normally people will say that it means many. Normally, I would say that it means many. But for our needs here, for this unit, we're going to say that it means one as well. Okay, so it can be 1 or 2 or 3 or 4. Basically anything greater than 1 or equal to 1. Okay, and a polynomial means one or more terms. Whoops. Keep forgetting to add the word or there. Okay, so polynomial means one or more terms. Okay, an example could be 2 terms, something like 3x plus 2. It could be one term like 3x, or it can be more than 2 terms, or more than one term really. 3x plus 4x squared plus 1. That's 3 terms there. Okay, for a polynomial function, a polynomial is just the sum of different monomials. Okay, so I didn't explain that one earlier, but that's what it means. For a polynomial function, it's just a function in this form. Okay, now although you are looking at this, I don't want you guys to get too worked up about it, because all of this is just sort of like filler. You see this an right here, this an right there, this, and this. It's okay if you're getting scared by this, because honestly, all this is, it's just a placeholder. A1, A0, an minus 1. All of these are just there because I don't want to put in a number. Okay, it just means that a number usually goes there. So this could be a 3x power of n. That could be a 4x power of n minus 1. That could be a 5x power of n minus 2. And then it would continue until you got to the 2. It could be a 2, x power of 2. And then we have a1. I can say that's sorry, I got ahead of myself. I could have that value be a 3, and then it'd be 3x. And then a0, that could be a 5. Okay, and basically those numbers are just placeholders. Now the n is different. N is going to be an exponent, and it has to be an integer exponent in order for it to be a polynomial. Okay, so this n, that n minus 1, that n minus 2, those are all going to be whole numbers. Okay, depending on what your n is, you're going to have a big polynomial or you're going to have a small polynomial. Like, let's say I had an n that was equal to 5. Well, then that means this one is 5. And then n minus 1, that's going to be 4. N minus 2, that's going to be 3. And so on. Eventually, you're going to get to x power of 2, then x power of 1, then x power of 0. Okay, right here, even though we don't have a 1 as our exponent, that's x power of 1. Even though we don't have an x power of 0 right there, that's still x power of 0. Okay. Normally we just don't write down the 1. Normally we just don't write x to the power of 0. Now, let me clear these markings. All right. So basically, it's just an equation that looks like a quadratic equation, but sometimes it's going to have more. Okay, just keep that in mind. Oops. All right. The a's are just coefficients, and the n stands for the highest exponent of x in the polynomial. Okay, so n, you got to remember, is going to be the biggest exponent. Okay. The highest exponent of x for a polynomial is called the degree of a polynomial. So if we had n equals 5, then that's going to be a polynomial of degree 5. If it had the biggest one was a 10, well then it's going to be a polynomial of degree 10, and so on. Okay, now let's say we had something that looked like this. Okay, x power 3 plus x power 2 plus 1. Well, this equation has a degree equal to 3. Okay, because the highest exponent is 3. Okay, even though it's in the front, it doesn't quite matter whether it's in the front. It doesn't matter that it has 3 terms. What really matters is that that highest exponent is equal to a 3. But what about here? Take a moment to think, what is going to be the degree of this function? Okay. Let me give you some options. Let's say A, degree of 2. B, degree of 4. C, degree of 5. Okay. And I don't know, D, 3. Okay. Ding, 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 ding. I don't know the Jeopardy song. All right. So, all right. I think that was enough time. If you said C, 5, you are correct. Okay. This has a degree of 5 because the highest exponent on x is a 5. Okay. It doesn't matter that it's 2 terms. Okay. It's not A. It doesn't matter that the one in the front was x to the power of 4. Okay, because the highest exponent is 5. If you chose D, I don't know what the heck you were thinking, man. Got paid to go back and go through the video just a little bit, and just one more time. All right. Yeah. So yeah, the degree of that polynomial is 5. Okay. Knowing what the degree is going to be pretty important later on for one of the next lessons, one of the other lessons. Yeah, one of the other videos. Okay, so we have a degree of the degree of a polynomial. It's pretty important. It determines what type of function the polynomial is. Okay, if you have a degree of 0 function or polynomial, this is called a constant polynomial or a constant function. If you were to graph it, the equation will look like this. It's a straight line. I know my squiggly line is not straight, but it's supposed to be. Let's say this is our x, this is our y. Okay. The way you can tell that it's in standard form is, well, the way that you can tell that it's a constant function. Sorry, not standard form. I just read that off the slide. Is by looking at the function and seeing that you have no x value, no variable at all on the equation. An example of this could be something like f of x equals to 5. Okay, your function equals to 5. This is the same thing as just saying y equals to 5 if you're not using function notation. Okay. It's just a straight line, just like I did. And now, if you have a degree of 1 polynomial, this is the same thing as saying it's a linear function. If you were to graph it, a linear function is not that far from being a constant function, except that instead of being a horizontal straight line, it's going to be a diagonal straight line. And this is our x, this is our y. The same thing as before. Remember I said these values, they're just filler. Like, you can put in a value in there if you want. In this case, my example was 2x minus 5. Okay, a linear function, that's a linear function. Okay, I have a minus 5. It doesn't quite matter whether you're adding them or you're subtracting them. Even though I put a plus here, it doesn't matter. Okay, it's still a linear function. Okay, next is a quadratic. You guys are used to these. We used quadratic formula. We used factoring. We we talked about parabolas. We talked about the vertex. We talked about I forgot what else. The axis symmetry. Well, that's a degree of 2 polynomial. Every single quadratic equation or quadratic function, that's a degree 2 polynomial. This is what it looks like, and you should already know the shape of the equation or of the graph. It's just like a U. It's a parabola. Degree of 3. Okay, well, degree of 3 is called a cubic function. It kind of looks like a Dasani symbol. Okay. And yeah, your highest exponent on x is going to be a 3. If you have a degree of 3, it's called a cubic function. Okay. The next one is called the quartic function. It has a degree of 4. Okay, it just means that we have x power 4. Doesn't matter what the numbers in front of the other things are, as long as that 4 is the highest exponent on that function. On x, I mean. And that one has a weird graph. Sometimes it'll look like this. Sometimes it'll look like that, like a W. Okay, it just depends on what the values are. If you were to graph this, I think this will probably look more like this. But if I were to have x to the power 4, well, that will look more like this. Okay, depending on what your polynomial looks like, the graph will look different. But yeah, just for the most part, it'll either look like this one or this one. Okay, so the degree of a polynomial. All right, degree of a polynomial, I just gotta emphasize that. Well, let's say we had x power 4, like that. This has a degree equal to 4, okay, even though it's one term. What about if we had something like this? Well, that has a degree equal to 4. As if we had something like this, well, that has a degree equal to 4. Okay, you see, I'm trying to tell you that the number of terms doesn't matter. We could have something like this. Okay, that's still degree equals 4. It could be something like this. Okay. Still, even here, the degree equals to 4. Okay, because it doesn't matter what the numbers are in front of the x's. It doesn't matter how many terms you get or how many terms you have in that polynomial. What matters is that you have your highest exponent be equal to the degree of the polynomial. That's it. Okay, so some more vocabulary here. Your leading coefficient and the constant term. Okay, so whenever you see that word leading, you should think line leader, right? And whenever you have a polynomial in standard form, your line leader is going to be the leading coefficient. Okay. I'll show you guys what that means in a bit. And then your constant term is like the bad kid in the group, the one that didn't bring his stuff to class. So he got punished and was put at the back of the line. Okay. This is the bad kid. Okay. Last one in line. Okay. So I'll show you guys which ones those are for an example at the very bottom, but let's go ahead and talk about this first. When writing a polynomial functions in standard form, you should and need to be able to tell what values these are. You should know what a leading coefficient is, you should know what the constant term is, and you should know the degree of the polynomial. Okay, these are going to be really important once we start looking at the graphs of them. For standard form, the exponents of x have to be in the right order. Okay, you're going to want to start from the highest and then bring it down to the lowest. Okay, and the order has to be from left to right. So highest on the left, lowest on the right. And sometimes a term might be missing. Okay, what I mean by missing is that there's not going to be a term in that spot, or there's not going to be a value there. Okay, it might be easier to explain it like this. Like, let's say we had x power 5 plus x power 3 plus x power 2 plus x plus 1. Okay, so we have 5, we have 3, we have 2, we have 1, we have x power 0, but we don't have x power 4. That's what I mean by missing. Okay, sometimes it's not going to be there. Okay, it's not bad. Most of the time, you don't even want to worry about stuff that's not there. But once we start looking at division, it might be a good idea to write in the stuff that's missing as well. Okay, it just helps you keep organized once we start doing that. Okay, so let's look at our example. We have f of x equals to 5x power 4 plus 3x squared plus 4 minus 2x power 3. Okay, I want to turn this into standard form. Okay, that means that I need to have my exponents, the highest exponents at the very front, they have to be the line leader, and then the lowest exponents at the very end, they have to be the bad kid. Okay, so let's go ahead and look at this. We have our highest exponent out of these three is the 4. So that's going to be our line leader. Okay, now this is our degree. That means we have a degree of 4 polynomial. And this number right here, the one in the very, very front, that's our line leader. That's our leading coefficient. Okay. As we go back or go over to the right, we're going to write down the next highest exponent. In this case, 3. So I'm going to write down x power 3. And because we have a minus there, I already messed up right here. We have a minus there, so this is going to be a minus 2x power 3. You have to make sure that you're subtracting the stuff that's being subtracted. You have to add the stuff that's being added. And if you're not sure whether it's being added or subtracted, just make sure that if the negative was there before, you want to keep it whenever you write it again. Okay. If there was no negative, then you want to leave it as a positive, or you want to write it down as a plus, as an addition. Okay. The next term is going to be the next highest exponent, which in this case is going to be 3x squared. So I'm going to write that in, plus 3x squared. Okay. And you keep going. Okay. There's no x power 1 here, so that term is missing. But just for the sake of it, I'm not going to write down anything there. At least not anything for x. Whoops. And then I move on to the next term. Well, my next term is 4. Okay. Now this is our bad kid. This is the last one in line. This is our constant term. Okay, so that 4, that's our constant term. Okay, now remember I said this is the bad kid. Okay, everybody else brought their x's, but this bad kid did not. Okay, the bad kid is always the constant term. It's the one that never brought its x's. Think about it as like the lunch. So because it doesn't have an x, it's a constant term. All right. All right, so now we're going to go ahead. Should I talk about anything else? No, I think that's about it. We have our leading coefficient, we have our constant term, we have our degree. Make sure that the constant term doesn't bring its lunch, meaning it doesn't have an x. Make sure that the leading coefficient is in the front. meaning that it's going to be next to the x with the highest exponent, and your degree is always going to be that highest exponent. So if you write stuff down in standard form, it should look like this every single time. Okay, now we're going to go ahead and add polynomials. This is not going to be that hard. It's actually pretty simple. Okay, if you know how to combine like terms, then you should know how to do this. Okay, when adding, order doesn't matter. Okay, order doesn't matter. It's fine. You can add f of x plus g of x, or you can do g of x plus f of x. Okay, in the end, whenever you're adding, you're going to get the same values anyways. So if you do 1 plus 3, it's the same thing as doing 3 plus 1. If you do 5 plus 8, it's the same thing as doing 8 plus 5. Okay. Whenever you start subtracting, whenever you start dividing, that's whenever it's different. But whenever you're adding or you're multiplying, order doesn't matter. Okay. That's called the commutative property of addition and the commutative property of multiplication. It just states that you can add or you can multiply in whatever order you want. All right, so x power 3 plus 3x is going to be our f of x. Okay. Normally I write these down in parentheses. It's just my way of doing it, but you don't have to. Okay. Oh, I guess I should have mentioned this. If you see f of x like here, you see how it says that it equals to x power of 3 plus 3x? Well, that just means that anytime I write down f of x, I'm really talking about this equation right there. Whenever you see g of x, I'm just really talking about this equation right here. If you see h of x, I'm talking about this equation right there. So whenever I add f of x plus g of x, I'm really just wanting to add this equation and this equation. Okay, so we have x power 3 plus 3x, and we're going to be adding the g of x function. So 5x power 3 plus 2x squared plus 5. Okay. So I don't think this one really needs 2 examples, so I'll only do the top one for now. Okay. And basically, anytime you're adding stuff inside parentheses, unless you have a number in the front, like a 3 right there, it doesn't matter whether you have the parentheses there or not. Okay, so I can really just write this down as x power of 3 plus 3x plus 5x power 3 plus 2x squared plus 5. Okay, adding doesn't matter. Okay, the parentheses doesn't matter unless we have a number in the front that we have to distribute. Okay, we didn't have a number in the front here, so we just add. You want to combine the like terms here. Anything that looks alike gets added up. I think that's the only thing that looks alike. So we are going to add up the numbers in front of the x's. Okay, even though there's not a 1 in front of that x power of 3, you can always add it on. It's always there if there's no number there. Okay, so we have 1 and 5. That gives us 6. Because we have x power of 3, I'm going to write that down. Okay. And then the next one. Okay, well, x power of 2, we want to do this in standard form. X power of 2, I'm going to write that down. And then I'm going to add up all the numbers that have x power of 2 as well. Since we have only a plus 2 right there, that's what I'm going to write down. There's only a 2. There's only a positive 2. Then we move on to the next term, the x's. Okay, well, this one's the only term that has an x. So this is going to be plus 3x. And then I finally move on to the constant term. This is the only number without lunch, without its x. So it's plus 5. That's our final answer. Okay. If you want to do it with g of x, you can. I guess I'll go over it. Why not? Okay, so g of x and h of x, we want to add those up. We have 5x power 3 plus 2x squared plus 5. Remember that I said since we're adding them, the parentheses don't matter? Well, I'm still going to add them in anyways. Okay, I can erase them afterwards if I really want to. But it doesn't make a difference either way. Okay. All right, so we want to add up the ones that look alike. In this case, this one and this one look alike. This one and this one both look alike, and that's about it. All right, so we have 5x power of 3 and 5x power of 3. I need to add up those numbers. 5 plus 5, 10. So we're going to have 10x power of 3. Then I look for the next term. Well, I need x squared. Okay, this is the only value with x squared, and it's positive, so it's going to be plus 2x squared. Okay, then I look for the x's. Okay, this is the only term with x next to it, so I'm going to write that down, plus 4x. Okay, and then finally, we have 5 and minus 5 being added together for the constant term. 5 plus positive 5 minus 5. Well, it can also be said positive 5 plus negative 5. It's the same thing either way. 5 minus 5 equals 0. So we can either write down plus 0, or because it doesn't change the value of the rest of the equation, we can just box only the front of it without the plus 0. It's up to you whether you want to do that or not. It doesn't quite matter. Anytime you have a 0 in front of an x, you want to assume that the whole term is equal to 0. Or if you just have 0 by itself, it's just 0. Either way, whenever you have 0 and you're adding it onto something else, it's not going to change the value of it. So you can always just replace it with nothing. Or meaning you can just take it away. All right. Now subtracting. Okay, now subtracting, this one's different. Order matters here. The parentheses matter here. Okay, we got to distribute. Anytime you're subtracting, you're gonna distribute. Keep that in your head. Subtract, distribute, subtract, distribute. Anytime you're subtracting polynomials, you're distributing a negative. Okay, order matters. Okay. Again, order matters. In case you didn't understand, order matters. All right. Just in case you forgot again, order matters. I don't only want to read your subtracting, okay, or your dividing, but order matters. All right. So in this case, we're going to be doing f of x minus g of x. We are going to need to write down those parentheses. F of x is still x power of 3 plus 3x. G of x is going to be the second equation, that one in the middle. In this case, it's going to be minus 5x power of 3 plus 2x squared plus 5. Don't forget the parentheses that I talked about. Okay, and now we are going to distribute it. We're going to get rid of the parentheses. The first equation you can always leave without any changes. Sorry, force a habit to write down the parentheses. But then the second equation, we are going to distribute that negative. This negative is going to go to this number, it's going to go to that number, and it's going to go to this number. And if there's more terms, they're going to keep doing it. Minus 2x squared plus 5. Whoops, that's not right. I forgot to distribute the negative. Minus 5. Yeah. Now I'm going to combine the like terms. That's about it. Everything else is different. We have positive 1x squared, x power of 3, sorry, minus 5x squared, 5x cubed, or x power of 3. Well, 1 and plus negative 5 will give you negative 4. You can also get this by just subtracting the two values, 1 minus 4. That's going to be, 1 minus 5. That's going to be negative 4. So we're going to get x power of 3 there. And then we move on to the next value, in this case, negative x power of 3. Oh, I have to get x power of 2, sorry. I wrote that down. Looks too much like a 3. Again. Should be a 2. Excuse me. All right, so negative 4x power of 3, we're going to have a minus 2x squared. We're going to have plus 3x. And then finally, our baddest kid in the class, minus 5. I know I said baddest. It was irony, I don't know. Okay, that's our kid without the lunch. All right, that's our final answer. Next, we can do another one. Okay, g of x minus h of x. Well, for g of x, we still have the same equation, 5x power of 3 plus 2x squared plus 5. And you can choose to put in the parentheses on that one. You can decide not to. It doesn't quite matter for the first term or the first function. But the second equation, we are going to need that parentheses. Okay. All right. So we are going to subtract these. We got to make sure that we distribute that negative, meaning that this negative will go here, it'll go there, and it'll go there. So we'll get minus 5x power of 3 minus 4x, and then negative times a negative will become a positive, so that's going to be plus 5 instead. Okay. After doing this, we're going to go ahead and subtract or combine the like terms. In this case, we have this and this. And then this one and this one. We're going to combine the values by adding the numbers together. So 5 minus 5. That gives me 0. So x, 0x power of 3 is what I want to write down. Okay, then you move on to the next highest exponent. In this case, 2x squared. It's only 2x squared, so I leave it as it is. Then I move on to the next term. In this case, minus 4x. So I leave it as it is. It's the only one. Then finally, 5 and 5. Well, 5 plus 5 equals 10. So I add them up. That's going to be my answer. Notice that right here we have 0x power of 3. Okay, well, normally you don't want to write that down. If you have a 0 in front of a term, you don't have to write it down. So really our answer is 2x squared minus 4x plus 10. This just means equals 0. If you add 0 onto anything else, whether you have it there or not, it's going to go away. Or it's not going to make a difference. So 2x squared minus 4x plus 10 is our final answer for g of x minus h of x. Okay, this is where I got g of x. This is where I got h of x. You want to make sure that you have the right order. All right, next one. Multiplying polynomials. Order doesn't matter. Okay, so just like I said earlier, order doesn't matter whenever you're multiplying or whenever you're adding. The reason being the commutative property of multiplication in this case. So if I decided to do g of x times f of x, like that, it's going to give me the same equation. If I decided to do h of x times g of x, the same thing. Okay. Now, I'm not going to have enough space to do the first one and the second one here, and leave the first one still on the slide. So what I'm going to do is I'm going to do the first one first. I'm going to give you guys a few seconds to look over it so that you can look at the video, and then I'm going to do the second one. Okay, so first one, we are going to take g of x or f of x and multiply it times g of x. That means that we're going to take x squared plus 3x. We're going to multiply it times 5x squared plus 2x squared. Whoops, you know what? I'm going to change this problem so that it has a 3 as an exponent. I guess I meant to do that, but I guess it slipped my mind. So we have 5x power of 3 plus 2x squared plus 5. Okay, that's much better. Okay, so what you want to do here is you want to make a box. You need one side to have two boxes, and you're going to make, well, 2 rows or 2 columns, and then you're going to make another side to be 3 rows or 3 columns. meaning that you can either draw a box that looks like this, okay, or you can draw a box that looks like this. Does it matter which one you choose? No, absolutely not. Doesn't matter which one. I preferred using this one though. You can use whichever one you want. And just for the sake of it, I'm going to make sure that you guys know that this equation is going to be the green one. This equation is going to be the red one that goes up here. Okay, you should know that because there's 3 terms on this one, there's only 2 terms on that one. So if I switch them around, I would have to have the other table, okay, or the other box. Okay, on the green side, we're going to go ahead and put those terms in there. X squared plus 3x, because it's plus 3x, it's just a positive, and since we don't have a number in front of 1x squared, I'm going to put a 1 in there, and it's the same thing. For the top, we're going to do the same thing, but with the other equation, we're going to write down 5x power 3, we're going to write down 2x squared, we're going to write down minus 5. Okay, next part comes easier. Okay, so what goes inside of the boxes? Well, on each side of each box, you want to look at the top, you want to look at the left-hand side of it. Okay, so whenever I look at this one, I'm going to be looking at this side, I'm going to be looking at that side. Whenever I look at this one right here, I'm going to be looking at this, and then I'm going to be looking at this one. Oops, sorry. Alright, so let me go ahead and erase that. Sorry about that. I just don't want to confuse you later on. Nope, that's not it. Okay. So this is the green side, this is the red side. And we are going to do the math inside of the boxes. Okay, so whenever I look at this box, I need to go look at the top, the 5x power 3. And I need to look at the 1x squared. Okay, so first thing you want to do is multiply all the numbers. Okay, we're going to do all the boxes, just multiply the numbers. 5 times 1 is 5. 2 times 1 is 2. Negative 5 times 1 equals negative 5. Then I move on to the next one. 5 times 3 is 15. 2 times 3 is 6. Negative 5 times 3 is negative 15. Okay, I'm done with that part. Now, we still had x's here. Okay, depending on the number of x's on top and on the left side, that's the exponent that we're going to go ahead and write down for the box on x. Okay, well, since we have 3 x's on top, we have 2 x's on the side. This is going to have 5 x's. Since we have 2 x's on top and 2 x's on the side, this is going to have 4 x's. We keep doing this until we get to the very end. There's 0 x's on top, there's 2 x's on the left-hand side, so that's going to have 2 x's. And then we have 3 x's on top, we have 1 x at the bottom, on the left-hand side, so that's going to have 4 x's. 2 and 1 will make 3. Oops, that's a 3. And then 0 and 1 will make 1. Okay. From this, I can tell what the answer is now, but I gotta combine some terms first. Anything that looks alike gets added. So these terms right here add up with these terms, and that's it. Okay, so our final answer is going to be, 5x power 5. 2 plus 15 equals 17, so that's going to be plus 17 x power 4. Then I move on to the next one. X power of 3 is going to be just 6x power of 3. Make sure to add it. Then the next term is going to be minus 5x power of 2. Normally you want to write these down on the same line, but I'm running out of space on the right hand side, so I just moved on to the next line, I guess. So we got this one, we got this one, we got that one, that one, and that one. The last one left is minus 15x. This is our final answer for this problem. Okay. Do we need a constant value here? No. We didn't have the values to make one. So it just stays that way. Okay. In this case, we have a degree of 5 polynomial as a leading coefficient of 5.
Hey, John.
Shh.
Oh, sorry.
And we have no constant term. Okay. Sorry about that. All right. Next problem. Let me go ahead and clear the markings. Next problem is this one. I'm going to go ahead and do g of x times h of x. G of x is going to be 5x squared plus 2x squared plus 5. And h of x is going to be 5x squared plus 4x minus 7. Okay. We are going to multiply these two equations, but first we're going to make our box. Okay. Because we have 3 terms and 3 terms, this means that we're going to need 3 rows and 3 columns. It doesn't matter which side is which, but I'm going to go ahead and highlight them anyways. Does it matter which one goes where? No. Can you choose? Of course. I'm just going to choose this one to be the red side, this one is going to be the green side. Remember, the order doesn't matter. If I had switched them, if I had done h of x times g of x, then the red one could have been green and the green one could have been red. Doesn't matter. Now let me go ahead and put my numbers in. 5x squared. Oh, that one was supposed to be 3, right? I changed it for the last one, so I'm going to change it for this one too. Yeah. 5x power of 3. We'll have 2x squared. And we'll have positive 5. And then we'll do the same thing for the next one. 5x squared, 4x, and minus 7. Inside of the boxes, I'm going to multiply the numbers first. 5 times 5 is 25. 5 times 4 is 20. Negative 7 times 5 is negative 35. 5 times 2 is 10. 2 times 4 is 8. Sorry about that. 2 times negative 7 is negative 14. 5 times 5 is 25. And 4 times 5 is 20. And negative 7 times 5 is negative 35. Yeah. Inside of these boxes, I'm going to put in my number of x's on both the top and the left-hand side. If the top has 2 and the left-hand side has 3, well then the inside of the box has 5. If the top has 1 and the left-hand side has 3, then this is 4. If the top has none and the left-hand side has 3, well then this one is 3. And you just keep going on like this. 2 and 2 is 4. 1 and 2 is 3. And none and 2 is 2. And then 2 and 0 is 2. 1 and 0 is 1. And then 0 and 0 is 0. So we don't write any x's down for that last one. These terms are similar to each other. These terms are similar to each other. And these terms are similar to each other. Okay. They have x squared. So what I'm going to do is I'm going to go ahead and write down my new equation, my product, going from the highest exponent and then moving down to the lowest exponent, and a constant term if I have one. So we have 25, oops, that's not 25. We have 25 x power 5. We have 20 and 10. That means whenever we add them up, it's 30. So plus 30 x power 4. Then the next term, this is x power 3, negative 35, and positive 8. That gives me negative 27, I believe. X power of 3. Negative 14 and 25 will give me positive 11. x squared. And then I move on to the next one. 20x is by itself, so I'm going to just do plus 20x. Minus 35 is by itself, so I'm going to do minus 35. In the end, this is our final answer for this problem. Okay. Normally, you want to write this down all in one line. So something like this. 25x power 5 plus 30x power 4 minus 27x power 3 plus 11x squared plus 20x minus 35. Okay, that's our final answer for that problem, for this one right here. That's basically it for now. You guys are going to have an assignment about these three things this week. Okay, it'll be due on Friday. It'll be about adding polynomials, it'll be about subtracting polynomials, and it'll be about multiplying polynomials. You're going to need to know how to add and subtract polynomials in order to learn how to divide them. That's the next step in the sequence, being able to divide polynomials. And just because we went over some vocabulary today, here's some stuff that I want to talk about. You might think, oh, polynomials, those are boring. I don't know why we're trying to learn about this. Well, many real-world problems can be modeled by polynomials. More specifically, by high-degree polynomials. Okay, so they'll probably have like x power of 100, x power of 200, something like that. If they can't be modeled by polynomials, well, it's okay because we can always approximate them with polynomials. Okay, for a small degree polynomial for a very short amount of data. Okay, or very small predictions. Okay, you might want to think, oh, okay, when are you gonna make a prediction? Well, people make predictions about this all the time. They make a lot of money on it. Okay, so this is the stock for Apple. Okay. What if you wanted to see whether you in the near future you're going to make some money? Yeah, sure, you can look at it for 1 year. You can look at it for 2 years. You might even look at it on a daily scale to see whether the function is going to be growing or decreasing. Or you can just look at the news, see what's happening. Maybe you won't be able to make a good prediction. But over a long period of time, a long-term time, like let's say 20 years or something, you want to know this for a long time. Okay, you want to make good predictions for good stocks that you want to keep until you retire. Well, that's whenever polynomials come in, and then you try to approximate them. Look at this. Okay, if we look back to this, you might think, oh, those don't really look alike. But what about if I told you to look at just one specific piece from here to here? Okay, look at it. It goes down, and then it goes up, and then it goes down, and then it goes back up. It goes down, it goes up, and then it goes down, and then it goes back up. And those are pretty similar. They're not quite the same shape, but I can always approximate it this way. Okay. This is called polynomial trending. And it's basically what happens whenever something doesn't increase as much as you thought it would. So they don't have a linear pattern. Basically, it's like if you put in money into an account or into an investment, you would think, oh, it's going to keep increasing over time. Well, not all the time. It's going to increase and then sometimes decrease and then increase again, something like that. Basically, it's going to have polynomial trending. And I'll leave it at that. Make sure to check your assignments. Make sure that you turn them in by clicking on submit work or add work onto your assignment. Some of you guys had trouble with that. Let me know if you need help with that. Worst comes to worst, you can always send them through the messenger, but please try to send your homework through Microsoft Teams instead of Remind at this point. I can check your work really quick on Remind, but with Microsoft Teams, I can keep better track of it. So in case you're not submitting it correctly, then I can always tell where it is anyways. All right, well, I'll leave it off at that. You guys have